All right, let's talk about one of those invisible heroes of the software world, Backpressure. It's the thing that keeps the apps and services you use every day from just completely falling over when things get crazy. We're going to break it all down.
So let's start with the question that probably gives a lot of developers nightmares. What actually happens when a system gets hit with way more data than it can handle? The floodgates open and it just keeps coming. What happens then?
Well, it's not pretty. The results are kind of brutal and, honestly, totally predictable. Systems don't just get a little sluggish, they crash hard. Memory just overflows, things start acting weird, you might even lose data. Best case scenario, your beautiful application just grinds to a halt. The stakes are really, really high.
To really get a handle on this whole thing, let's use a super simple analogy. I want you to forget about code for just a minute. Instead, let's talk about a water tank and a pipe. This story perfectly explains the whole problem. Okay, so picture this. You've got this absolutely massive water tank. It can just blast out water at a crazy speed. Now, imagine you connect that fire hose of a tank to this teeny tiny little pipe. A pipe that can only handle a trickle. Yeah, you can probably see where this is headed, right? Exactly. It's a total disaster. Water is spilling everywhere, the pressure builds up and up until something gives, and the whole system just breaks. And that right there is a perfect picture of what happens when a fast data producer just completely overwhelms a slower consumer. So how do you fix a mess like that? How do you go from total chaos to having some kind of control? Well, the answer is actually incredibly simple, almost elegant.
You add a valve. That's it. Just one simple component that suddenly gives the pipe the power to manage the flow. And this is an absolute game changer, because it totally flips the power dynamic of the whole system.
Now, the really cool part is the pipe gets a voice. Instead of just being this passive victim getting flooded, the pipe can now actually communicate. It can basically shout back to the tank, "Whoa, hey, slow down. I can't take all that. Send me only what I can handle right now." And there it is. This is the moment we tie our little story back to the tech. That valve, that whole idea of the consumer signaling back to the producer what it can handle, that is what we call backpressure. It's a feedback loop, and it's what brings balance and sanity back to the system. So let's just map it out to make it super clear. Our giant water tank, that's what we call a publisher in the programming world. It's what produces all the data. The little pipe that's trying to keep up, that's our subscriber. It consumes the data. It's as simple as that. Okay, so we've got the concept, but how does this really work in the real world, in actual code? Well, this is where you see that power shift I was talking about. With backpressure, the consumer, not the producer, is in the driver's seat. The whole process becomes this nice, polite, controlled conversation. It's pretty simple. First, the subscriber says, "Hey, I can handle, say, 10 items right now." Then the publisher sends exactly 10 items, and no more. The subscriber does its work, and once it's ready, it just asks for the next batch. See the difference? We've turned a chaotic push system into an orderly pull system. And the benefits? Oh, they're huge. You get this nice, smooth flow of data. Your system never gets overloaded because it's never sent more than it asks for. This means you get predictable performance, and, this is the big one, your precious resources like memory and CPU are totally protected. So, if you're going to take away just one thing from all of this, let it be this. In a system that uses backpressure, the consumer, our little pipe, the subscriber, is always in control. It calls the shots. Period. Okay, this all sounds like a neat idea, but let's talk about why it's so much more than that. Why does this concept have such a massive impact in the real world? Why should you, as a developer, really care about this? I mean, just look at the two scenarios side by side. It's like night and day. Without backpressure, you get chaos. Data just piles up, memory gets swamped, and eventually, the whole thing crashes. But with backpressure, you have order. The load is managed, the system is stable, and your applications become way more resilient. And this isn't some obscure academic thing. This is the bedrock of so many services you use every single day. Think about massive APIs like the ones at Google or X. They'd collapse without backpressure. Or streaming platforms like Netflix and YouTube, that smooth video playback, you can thank backpressure. The entire world of modern microservices, it literally wouldn't work without this concept. And for all you developers out there, especially in the Java world, this is baked right into the tools you're probably already using. Frameworks like Project Reactor, Spring WebFlux, and RxJava are all built around this idea.
It's not an afterthought. It's a core, non-negotiable principle that lets a subscriber literally request a specific number of items. The theory is right there in the code. So let's bring it all home one last time. If you remember one thing from this whole explainer, let it be our little story. A fast tank and a thin pipe is a complete disaster. But when you add that little controlled valve, you get backpressure. And with backpressure, you get a system that's stable, safe, and can actually scale. And that kind of leads us with the final question, doesn't it? Backpressure is one of these amazing, often invisible systems that's constantly saving our digital world from chaos. It just makes you wonder, what other elegant, hidden solutions are out there quietly working behind the scenes to keep everything